Okay, I'm recording this Loom video to show one option for private key management that has a few advantages over the usual way that developers manage private keys for Ethereum accounts, which is by using a .env file which stores the private key in plain text. That private key normally is treated as a hot wallet, so risks of losing funds are low, but it does happen. And it actually is the third highest dollar amount attack vector of Ethereum hacks. As you can see here, stolen private keys accounting for 137 million. So yes, this sort of thing does happen. And so a potential solution is to encrypt the private key into what's called a key store file, which if any of you have used to like Thorchain or certain other blockchain networks, Cosmos, I think, uses key stores pretty heavily. It basically provides you a file that will only return the private key if you give it the correct password, which has the advantages of that key store file being generally pretty fine to share or leak because it's encrypted. And assuming you have a strong enough password, then people can't access the private key within it. So I will show you the process of doing that. First, we'll generate a private key and the address associated with it. So let's call it a beef address. You could also just run cast wallet new, but I like the vanity addresses. So here's our address, oxbeef, and this is the private key. Okay, so I'm going to go ahead and copy that to the clipboard. Then we use Forge's wallet import functionality. It gives you an interactive prompt, and let's call it beef to go with the name. Oh, I already created one. That's right. Let's just call it beef too then. Alright, so I copied the private key, which is over here. You won't be able to see it as I paste it, but I did. And let's choose a secure password that is 20 characters long. And that's important, like I said, because the password needs to be 20 characters in order to be strong enough for it to not be brute forced. And ideally it uses capital letters and numbers. So we're using Natoshi Sakamoto 69420, capitalizing the swapped letters and using numbers at the end, totaling 20 characters. The reason for this is because a key store is not like a social media platform where they can rate limit brute force attacks. Basically, they can rate limit scripts or password crackers that just spew random passwords over and over again into the password prompt. Key stores don't have the ability to block that, whereas Facebook and Instagram do. They'll limit it to maybe 10 attempts and then lock the account. The key store, on the other hand, if it ends up in the wrong hands, somebody could just set a password cracker running on it, for days, weeks, even months in order to try to crack it. So it's important to have a strong password. Again, the criteria I usually use are 20 characters, capital letters, numbers. Special characters are great too, but if you're hitting the 20 character amount, that's usually plenty. Okay, so then we have the key store generated and it's encrypted. So now we can use that key store by just providing it as a flag to Foundry commands. So one example of this would be forge script key store, and then we would give it beef2 because this is my second Loom attempt here, and provide the password, which we know is Natoshi Sakamoto 69420, and then here we would have some script that's being run, and that way the private key is never exposed. There's no risk of it being pushed anywhere in plain text because it's not stored in plain text, it's encrypted. Yeah, so those are the benefits of using the Forge wallet key store functionality. again, maybe not necessary for a use case, but good to be aware of since it'll probably become more standard as time goes on.